Yes, you can see this is a ring footing. This is a ring footing. This is a ring footing. The intensity of loading is given 250 kilopascal. Now, actually, this ring having the ring having external diameter, what I say, outer diameter, and it has inner diameter also. Both are given actually. So here you see the inner diameter, and you can see the outer diameter. The inner diameter is 3 meter, and the outer diameter is 6 meter. Outer diameter is 6 meter. Now what I have to do now? I have to calculate the intensity of vertical stress. The intensity of vertical stress at a depth that is 3 meter below the ground surface. So here you see the inner diameter, and you can see the outer diameter. The inner diameter is 3 meter, and the outer diameter is 6 meter. Outer diameter is 6 meter. Now what I have to do now? I have to calculate the intensity of vertical stress. The intensity of vertical stress at a depth that is 3 meter below the ground surface. If it is a circular footing, we are ready to tell the stress at any depth z. Okay, so we are ready to answer this question. We can able to calculate vertical stress at any point P. So that formula is with us. If you see here, the outer diameter I am designating with capital D, and the inner diameter I am designating with small d. Now I have capital D. You know that this diameter is capital D. Now I need to calculate vertical stress at any point P, which is at a depth of 3 meters. So you are ready to say the answer. Sir, I know this answer, Q into 1 minus cos cube theta. I can handle cos theta because this is theta. So you can comfortably say sigma z is equal to Q is given 250 kilopascal. So you are very good in handling this cos cube theta 1 plus A by z square whole power 3 by 2. To us it is 6 meter. So now the radius, can anyone tell me now? 6 meter by 2. So I can able to calculate stress due to circular load, but I'm not ready to calculate stress due to ring footing. Actually, ring footings are quite common for water tanks. So now what I have to do? I have to do minus. Now I'm trying to select another circle. I have 2 circles here with the inner diameter. See, this is a circle I have considered, but this time I'm going to calculate stress due to this smaller circle. At the same point P, which is at a depth of 3 meters. Now what I am asking you, how to calculate sigma z due to big circle and small circle. Now how to calculate now? Sigma is equal to Q into 1 minus cos cube theta. Now the thing is how to calculate cos cube theta. 1 minus this is 1. No doubt this is 1. This is 1 because otherwise you may mistake it. 1 by 1 plus. Now let me tell you a radius. What is the radius in this case? What is the radius? Here you see the inner diameter is 6 meter. Now the radius is 6 by 2. So I'm sorry, inner diameter is 3 meter. Inner diameter is 3 meter. Now 3 by 2. Now the radius is 1.5 meter. Here you can see in question, the outer diameter of the circle is 6 meter. The inner diameter of the circle is 3 meter. 3 meter. So it is 3 meter. Now 3 by 2 is 1.5. Now we can write here. So a by z, z is 3. What is my small a? 1.5. This will be whole square whole power 3 by 2. This you please. I have outer circle. Now I have inner circle, but I want ring, stress due to ring footing. So this is a frequently asking question. So if you want to calculate stress due to ring foundation, so what we have to do now? Stress due to outer circle minus stress due to inner circle. Z is equal to sigma z ring is equal to sigma z outer circle minus sigma z inner circle. So get ready. We are using Bouwsnick's theory to calculate vertical stress due to ring into 1 minus 1 by 1 plus. For your convenience, I will write capital R by z whole square. This is whole power 3 by 2. Now close the bracket. This is for outer circle. Now coming to inner circle, minus. Can anyone help me now? 2 into square whole power 3 by 2. Now this is Q is 250. Now take this curl bracket 1 minus. Now 1 by 1 plus R. Capital R is there. What is the capital R? Capital R is given. See please, why I am writing R is radius, but outer radius, where small r is inner radius. I will write without any doubt. So now capital R is 3. The reason 6 by 2. That is 3. Depth, I want to calculate vertical stress at a depth 3 meter. So now whole power 3 by 2. So minus 250. 1 minus 1 by 1 plus R by, here is a small r is there with me just now, 1.5 by z is 3 whole square. This I need to do 3 power pi by 2. So usually, so you need to answer like this. Get this value minus get this value. Tell me the answer in kilonewton per meter square.